This assessment asks us how we might reduce a carboxylic acid in the presence of an aldehyde. Now, typically to reduce carboxylic acids, we would use lithium aluminum hydride, but we know that aldehydes can be reduced by lithium aluminum hydride as well. In fact, aldehydes are more reactive. So if we were to treat this molecule with lithium aluminum hydride, we would almost certainly reduce the aldehyde first. How can we prevent that? Well, we can go back to our protecting group strategy. So we know that we can protect aldehydes using ethylene glycol and some acid like sulfuric acid. That would give us a molecule that has the aldehyde protected and would leave behind the carboxylic acid. Now, it's possible that in these conditions you might get some Fischer esterification with the ethylene glycol. The reality is, for the purposes here, that's not going to matter, because now if we take this and treat it with lithium aluminum hydride in ether, follow that up with an acid quench, we will reduce that carboxylic acid all the way down to an alcohol. So we'll end up with the primary alcohol, and that acetal functional group will remain untouched. All that remains as part of that protecting group strategy, we protected, we ran the reaction we were protecting it from, and now we can remove that protecting group by reversing, adding sulfuric acid and water, and probably heating it to push the reaction to regenerate the aldehyde. So if we want to reduce a less reactive functional group in the presence of a more reactive functional group, we need to protect that more reactive functional group, in this case, protecting the aldehyde.